Position. Say, we learn rectilinear. New, uh, erratic motion. So when we define dynamic motion position E as so there's a definition for displacement, which is n position minus early position. Velocity is it's a time differentiation and it's not division. Acceleration is dv dt plus time differential of your velocity. And with E, you get one new equation, which is A dv A dx equal to B dv. Then there are three Newton motion equation, which is V equals VO plus AT. V VO dvt. V what? Go to half AT square. V what? V square. V square go to V naught and then delta S go to U. So these three equation is important. Then for erratic, we have a few graph. ST, VT, AT, and two more graph, which is BS and AS. Okay. So when you move S to VT integration to y dx, same V to AT, you do integration dy dx. But if you reverse back AT to VT, you do integration. And you do VT to ST, you do integration. Okay. To solve from AT, VT, ST graph into these two graphs, AS graph, what you do, you freeze the time and you use AS ds equal to V dv. Okay. I will give you the tutorial question, and we already discussed one final year question in the previous lecture. Okay. So there's no reason you don't know how to do when this kind of question come out in your test one. Okay, we have completed rectilinear. Then we go into curvilinear motion, which is a curve. So when we deal with curve, we deal with position also, but we are referring from a center of a curve by the radius of the curve. Okay. And every time we will deal with two parameters, which is the velocity and acceleration. Important, you know how to draw the direction of velocity and acceleration on the curvilinear motion. It applies until the last chapter of this module. So if you want to draw the V velocity, what do? you use your ruler, pick the point, and draw tangent direction for the V. Tangent direction is always tangent direction towards the center with the R. So means this R is, okay, this R is perpendicular to the velocity, and you want to draw acceleration. Acceleration always pointing inside the curve. Always pointing inside the curve. This is your A. Always pointing inside to the center of the curve. So this is the thing that we do. And then recall that what we're dealing throughout the module is we are dealing with vector, and it's not a normal numbers. So vector, you have magnitude and direction. So velocity, you can break into the Vxi plus Vyj plus Vzk. So what is Vx? Vx is actually the displacement of in x direction over time, which is here. Same with rectilinear, but it's in the x direction. Apply for x, y, and z. And there's a direction. Okay, to find, because this is vector, you have magnitude and direction. So how to find magnitude? You find magnitude by applying the vector application, which is Vx squared plus Vy squared plus Vz squared. How you find direction? Direction is actually the angle. So direction, what you take? You take the vector divided by the magnitude of the vector. Okay, you take this one divided by this one. Apply the same for acceleration. Same, acceleration the same. Also have x, y, and z direction. So that is where we stopped in previous lecture. Okay. Today we look at application of what we learned. We go through maybe 2 or 3 examples. And during the derivation, we need to remind you, you need to use change rules when you do differentiation over here. Because you are differentiate x, I, y, I, z, I. So this is actually a u and v. So when you differentiate u, v, you need to split into 2 procedure like this. So we cancel one of it, apply for all the x, y, and z. Okay. Let's look at this tutorial question. Example 6. Let's say you fly a balloon, a weather balloon, and you tie this weather balloon with a flexible wire or rope. And this rope, it can be extended, for example, the position you fly in x direction defined by x equal to 2t. So this balloon will move in x direction in 2t. T is a second. So equation of the path is y. So meaning the path of this balloon is given you by y equal to x squared divided by 5. Determine the magnitude and direction of the velocity and acceleration when t equal to 2 seconds. So how do you solve this one? You have to see the question as a vector question, right? Not a normal physics question, is a vector question. So you convert what you know into a vector question, right? So you have y equal to x squared divided by 5. And you have what else? you have x equal to 2t. So just now we learned about the vector for velocity. So velocity equal to x direction, velocity x direction I plus y, vy, j, and vzk. So from these two equations, are you able to find Vx? What is your Vx? What is your Vx? What's the definition of velocity in x direction? What is this? What is this? What is this Vx? Let's understand why how you arrived at these two equations. Understand, right? Or blank. So if you don't understand this one, go back to the previous video and watch it. Okay. So Vx equal to dx dt. So we have two equations there. Which equation you are going to use? You're going to use this one or this one? First one is what? Your x movement, your x position, and time. So which equation you're using? This one or this one? This one. X equal to 2t. Are you able to do differentiation? Dx dt equal to what? Equal to 2. So this one equal to 2. You guys understand what is happening here? Who don't understand this equation? Who don't understand this one? Okay. We just convert accordingly and simplify. Just write Vx, Vy, Vz. You have two equations. You're given two equations. You have x equal to 2t and y equal to 1 over 5 x squared. Now the first equation, Vx equal to dx dt. So you differentiate this one. Differentiate this one. You substitute the x there. Substitute this one, differentiate, you get 2. Vx is 2. Don't forget the unit. What is Vy? What is Vy? Vy is what? What is Vy? What is Vy? What is Vy? Huh? What is Vy? X over? You understand this one or not? You understand what is this or not? Then you understand this one or not? So what is Vy? Huh? What is Vy? This one. Dy dt. You have y equation. How to do dy dt? Huh? What? Okay. 8 over 5. You dy dt. So basically you are doing differentiation of y. 1 over 5 x squared. Sorry. X squared. But here, because there is no t, you replace x equation over there. So the x is equal to 2. Which one should we have? No problem. Direction is to the right. Okay. So please remind yourself you are dealing with vector. What you're calculating here must have magnitude and direction. Huh? So velocity here is to x. So velocity in y, you differentiate this equation, but this one you don't have t. If you continue this equation, what you get? 0, because no t there. Not 0, but there's no t. So you still get the same thing. So because no t here, you're unable to do anything. But you can replace x in terms of t. In this case, x equal to 2t. Okay. So what is the answer? 8 over 5. Okay. Good. Any question? Any question? Anyone you're not sure what we are doing here? What is the direction of Vy? Going up, Direction is going up. Okay. All right. Now, if you're weak in differentiation, integration, please do your homework. Our class is engineering dynamic, it's not mathematics class. Okay. And throughout my experience, students fail in this module not because he or she don't understand. He failed because he's weak in differentiation and integration. He do halfway, then don't know how to continue because of mathematics steps. Okay, so go and polish up the integration or differentiation. Okay, now what happened to the z direction? Anyone? What happened to the z? No z. Proper answer is the question. What is the assumption of the question for z direction? What is the assumption for this question? What happened to the z direction movement? There is a z direction movement, but what? It stay in z axis. All right, means dz dt equal 0. Although it's not mentioned here, but it can be a very bonus. It's just a bonus mark. It just test your understanding. What happened to z direction? Explain what is the behavior of this balloon in z direction. Basically, what you need to answer is stay in z direction. There's no changes in z direction. So dz dt equals 0. Makes sense. Yeah. So you are at a degree level already. We expect you to have some critical thinking and understand the value and what is happening in the equation. Okay. All right. So he asks you what happened when the time equal to 2 seconds. What you do, you just substitute inside there. Okay, inside there for Vy, you'll get 3.2. And then I go very fast. How to find magnitude? Not magnitude, direction. You have two vectors. One is Vx, one is Vy. This vector. So once you have a vector, this 90 degree, you have an angle there. Recall your trigonometry equation. Tangent theta equal to opposite divided by side. In this case, Vy, Vx. You want to find the angle. Theta equal to tangent inverse of your Vy, Vx. Okay, substitute, you get 58 degree. From where? You have to know, 58 degree from where? From the horizon of x, based on your free body diagram here. okay, from X. Positive value, anti-clockwise. Yeah. So start to think or start to solve problems by asking yourself what does this vector going? What is the magnitude of this vector? Okay, you won't see this kind of question in statics, but when it comes to dynamics, you always need to ask what is the magnitude and what is the direction, right? From where? Okay, you are referring from where? In this case, you are referring from X, point A, and it is looking up, right, for the 58 degree. Okay. So what about acceleration? You know the velocity, right? So acceleration, same. So now you have this one, you have your Vt, you have Vx, Vy, Vz, same apply for your Ax, I plus Ay, J plus Az. What is Ax? Back to the rectilinear definition, what is your A? dV, dt in X direction plus the same in Y direction plus the same in Z direction. Okay, what is your Ax? What is your Ax? What is your X? What is your X? If you want to find your acceleration in X direction, what is your X? You take what? dV dt, right? In X direction. What is the value of Px? 2. So what is your X? 0, because there's no T there. What is your Vy? Your Vy just now got one equation. So your Ay equal to Vy Vt. This is Vy Vt. Vy is in the equation 8/5 T. So you need to differentiate. Right? What is the answer for when you differentiate time? Right? You need to polish up your differentiation. What is the Ay? When your Vy equal to 8/5 T, what is your Ay? What is the definition of A? dV dt. Answer is 8/5. Unit meter over second square. Okay, polish up your differentiation. Polish up by this week. If not, you're going to float around and you'll not understand what we are doing. Because in later chapter, you are heavily depending on differentiation and integration. And it's a double differentiation and double integration. Polish up by this week. If you're very weak in differentiation and you don't understand why Ax or Ay equal to 8/5 for this example, polish up your differentiation. Okay. So you do differentiation, Ax equals 0 means no acceleration in X direction. Means no changes of velocity in X direction. Your velocity in X direction maintain at one value, constant value, which is 2 in this case, right? Ay, like what we did, is 8/5. You can remain your answer in fraction, or you can remain your answer in decimal place. Minimum 2 decimal place, maximum 3 decimal place for this module. Remember the unit. What happened to the Z again? 0. 0 because Z don't have velocity, so no acceleration. Okay. So you take this magnitude again, write the general equation first before you substitute value. There is a marks for general equation for this module. You write general equation, then only you substitute, because sometimes your brain will play games with you. You know the answer, but when you write on your answer sheet, sometimes 9 will become 0. 9 will become 0. And then sometimes your decimal place, somehow you're missing. Write the general equation first, then substitute. Okay, ax squared plus ay squared plus az squared square root. Press your calculator, you get the magnitude. Same. Here you have acceleration in x direction, acceleration in y direction. Again, it's a vector question. Ax, ay, you have a right-angled triangular. You have a theta, apply the same tangent theta. So tangent theta equal to opposite divided by side. So ay divided by ax. Press your calculator, you also get the answer. Okay. In this case, it's 90 degree. So when you have an angle of 90 degree, it proves that yes, at the end, there's no direction in x and it's going in y direction. So this is how you check your answer. Okay, so go home and polish up your one. So once you calculate your answer, go back to the free body diagram or your answer sheet. Go and draw the direction, the vector inside the diagram. For example, this case, this is acceleration ay, ax. Where is the resultant? Resultant is in ay. There are three vectors you should know, ax, ay, az, and then the resultant. The resultant in this case, you already calculated. Resultant, you combine these two, you're in 90 degree. So same with acceleration just now, right? Same with acceleration just now. So acceleration question, same. You draw your Vx, Vy, and then your resultant. Maybe this one just now I go very fast, I didn't mention. But every time you calculate something, mark that value on the free body diagram. Okay, we completed example 6. You get the idea. Actually, the application of this equation that I write on the whiteboard here. V, you expand to x, y, z direction. Then remind yourself, this is vector and magnitude. How to find magnitude? Square the x direction, square the y direction, square the z direction, square root. Direction, you take the magnitude, take the vector divided by magnitude. Apply the same for acceleration. Okay, let's do next question. For a short time, remember sign your attendance, those come late one. Okay, so for a short time, the path of the plane described by y equal to 0.01 x squared, and you're given this diagram x and y. You know there are three kind of line on the graph: linear graph, quadratic graph, and polynomial graph. So by referring to the question y equal to 0.01 x squared, you know this is a quadratic graph. So quadratic graph, positive value, your a value is positive, so this is a smiling face. So it will be a smiling face on the graph. Okay. So this is a tutorial question. When it comes to test or final exam, sometimes we don't give you the line. We just draw the axis for you, put the object on the graph. You need to develop the path for the object. Okay. If the plane is rising at a constant upward velocity 10 meters per second, means this aircraft move constantly upwards. Determine the magnitude of velocity and acceleration of the plane when it reach altitude y equal to 100 meter. How do you solve this question? Okay. Rice, you have an equation there. He asks you to solve what? Velocity and acceleration. So to solve this kind of question, don't panic. First, ask yourself what you learned in this chapter 1. You learn about definition of velocity and acceleration. Write the definition of acceleration and velocity. V equal to ds dt, A equal to dv dt, and also there's a definition for acceleration you can write in the position, where is d square s divided double time differentiation of your position. D square s and then divide by dt square. It's a double differentiation. So in this case, you have a y and you have a constant velocity pointing up. Okay. So you do, you need to find at 100 meter what is the acceleration at that point. Okay. So you have an upward velocity of 10. What is the information give you? Again, velocity have three vector, three direction, vx, vy, vz. In this case, you are given the vx direction. So vx equal 10 in the question. Sorry, upward, in this case, vy, not vx. Vy equal to 10 meter per second. So what else? So at 10, when your vy is 10 meter per second, at y equal 10 meter per second, what is your x? It's plotting a graph, right? Plotting a graph. So you have a line here, y equal to something quadratic equation. You're given the y value. What is the x direction? What is x position here? You just substitute, right? Substitute your y equal to 100 here. You're solving quadratic equation. And quadratic equation in this module quite tricky. You have positive value and negative value. You have two roots when you have quadratic. You solve for square root of your quadratic equation. You have two roots or two solutions. One is negative, one is positive. Sometimes the question will ask you, why do you choose that number? Because in this case, in the dynamics, positive means is follow your positive axis, means your positive direction. You get negative means it go against your free body diagram. So you need to choose carefully the value, either positive or negative. So what is the answer? Press calculator. What's the answer? What you get? 316. 316.23. In this module, minimum 2 decimal place, maximum 3 decimal place. Okay. I'll go very fast a bit because we only have 1 hour. So from the graph, we have 2 points. One is y equal to 100, x equal to 16.3. So from here, you have one equation, y equal to x 0 point something, x squared. And from 0 to 60, you have your x and you have t. What else? Okay. Can you find time? Can you find time? Again, this module, you are dealing with position, velocity, acceleration, and time. Now you have velocity, later you find acceleration, you have the position now. You have what? Vertical velocity. You have 100 meter. Can you find time? Try to think. Can you find time? Can, right? You know that you are climbing at 10 meter per second. You want to reach 100 meter. How long it takes to reach 100 meter? How long it takes? 10 seconds. It means the whole motion happened in 10 seconds. From here to here, here to here. Make sense? So you extract information one by one. You don't panic and then you start to think like the 4 parameter you need to get from all the answer in dynamics: position, velocity, acceleration, time. So you look at this question, you have the information 100, you have the position of this one, and you have a vertical velocity. So ask yourself, it will take 10 seconds to reach 100 meter. So the whole motion is 10. So you know the x velocity, right? Once you have the time, x velocity, right? Okay. So y equal to vt and so on. So time is 10 seconds. This is a hidden message. So you need to like try to think like, okay, what information I have, then how do I relate to what I learned before this? Okay. Once you have time, sorry, I show you the answer already. Once you have time, so again, you need to apply chain rules and go to Canvas, download Appendix C. If you haven't, Appendix C, well, you will see the name of the document is chain rules. Go and see, it's a vector revision material. Go and see how to do chain rules if you already forget, right? So we already see these chain rules in the previous section when we derive the dx, vx, vy, vz. Okay, so you are having y equal to 0.01 x squared. So dv dy, velocity in y equal to y dt, right? So in this case, your time differentiate of your 0.01 x squared, because your y equal to 100 x squared. In this case, you need to apply chain rules because this is u, this is v, right? Because you're differentiate with t, there's no t there. What is chain rules? Y equal to u v means you create something to differentiate. Dy dt. So du, go and see the appendix now. Okay. So what you do is that you take dy dx dot dx dt. It's a chain rules procedure. All right. Basically, if you take out this one, it's the same as dy dt. You're creating something out of nothing. Right? It's a mathematics tricks. Right? Again, if you don't know what is this, go download Appendix C in a Canvas. Right? Look for how we apply the chain rules. So you have dy dx. Dy dx is what? Dy dx. Your y is this one. The y is this one. So you are doing the normal differentiation. Dy dx, you move. This one you remain. You move the 2 in front. So 0.002 x 2 minus 1, you get this one. Dx will remain. Dx dt. You do the first one first. Then you convert dx dt equal to velocity in x direction. Make sense, huh? Okay. Then you substitute. You have your x on the graph. This is the relationship given to you. 100 meter. When you reach 100 meter, your x will reach 310.23. So how we get this one? We already explained it just now, 5 minutes ago. Right? Substitute this one. You have one value here and one unknown. Move this one to the left. You'll get 15.81. The catchy part here is chain rules. If you don't see this question as a chain rules, you're not able to answer. You will stop there and try to think like, how do I solve this? Okay. So polish up your differentiation skill, differentiation skill including chain rules. Chain rule is one of the differentiation chapter. Okay. Once you find the answer, go to the free body diagram, draw your velocity vector pointing up, Vy 10 meter per second, given in the question. Vx is over here, 15.81. Again, this is vector. Vector have magnitude or resultant magnitude. Pull this one over here, form a vector triangular. Is a right-angled triangular. Pull out trigonometry. In this case, tangent theta. Okay, tangent theta. So you apply all the procedure. So magnitude in this case, there's no Z, means we assume that the aircraft is following the runway. It do not like move up or move to the left or right, right? So you do the procedure, you get the magnitude and the direction is tangent and so on. Any question? This is a second repetition from the example number 6. Example 7 is a reminder for chain rules. Okay, so today your homework is to go to Appendix C and refresh how to do chain rules, because in later chapter you will continue to see your problem as a chain rules problems. Okay, all right. I think we are done. Okay, so just now we're done with the velocity. What happened to acceleration? Apply the same procedure, but now you're looking at the acceleration. Ask yourself, what is the definition of acceleration? dv dt. So you already have equation for v just now. So do the same, like what you see in the example 6. Okay. So you have first equation given by the question y equal to something x squared, and just now you convert this one then the second question answer just now from the velocity Vy equal to 0.2 Vx, right? Where you get this one, you get from here. Get from here. Vy equal to 0.02 x Vx. Okay. So dynamic question, you need to be careful on your equation. You derive the general equation first, then only you substitute. Don't straight away substitute value. Create the relationship between position, velocity, and then acceleration. If can, find the time. If cannot, usually the question will give you the time and then ask you what happened to the velocity and acceleration or position. Okay. Changing the way you study for engine dynamics. Okay. So your ay equal to dy dvy over t. This is the definition for acceleration. You take time differentiation of velocity. But in this case, you have y direction. So again, chain rules. Apply the same chain rules for acceleration. Just now you do for velocity. Now you do for acceleration. So d uv equal to u dv dt plus v du dt. Okay. So you apply the same, this green color procedure. Okay. Then when you do the chain rules, green color one, you need to have a boundary condition. What do you mean by boundary condition? Starting point or end point. Any one of the point that you know from the question. In this case, you know 2 points. One is 0 point, but it give you nothing because you use 0 you come out with 0. Another point is here. This point will give you information. You use when u equal to let u equal to 0.02 and v, this is the, you let the which one and which one. So you are using this one, this equation. A equal to dv dt. So you pull out the dt, you actually seeing converting this vy equal to u and v form. So you break this one into two forms. This is u, this is v. Okay. Then go to the procedure there. If you don't understand this one, go ask your mathematics lecturer. Okay, once you have that one, you arrive at this equation. Okay, so this basically we rewrite this one equal to this form. So we just copy this one over here. How you get this value, refer to the previous slides, earlier section. We arrive at. Okay, then the rest is differentiation. Okay, dv dt is acceleration. dv dt acceleration in x direction because this is dealing with x. And then v is vx. du dt, what is your u? Your u is this one. So you differentiate this one with time, right? And you complete the procedure, you arrive at this one. You arrive at this equation. Ay equal to 0.2 x ax plus vx squared. Then you substitute the coordinate you know from your graph. So when x equal to this one, your velocity is vy, because at this location, your vy just now you redraw, vy equal to 10, vx equal to 15.8, right? So vy is a constant value. When you have a constant value, it means your acceleration is 0. Okay, so this is also another weak point I see over almost every semester. When we give you a constant value, you don't know what to proceed with the acceleration. When you see constant value, you differentiate, you get 0. Okay, so substitute your ay 0, then you do the rest. You substitute your vx, you know your vx here. So there's only one unknown in the equation. Okay, you get negative. Negative 0.791 meter per second square. What mean by negative in this chapter? The acceleration means it slow down. Acceleration. Okay. Continue. Find the magnitude. You have your ax and ay. In this case, what happened to your ay? Ay 0. Because this is a constant value. So you get the same. You square the same value, square root the same value, right? Square and then square root. This is 0. You get back 0.79. Direction. You have two direction. You know that this one is 0, right? You divide 0, divide by something, you get 0. Or you divide something 0, you get error. You get infinity. Okay. So what I mean by 0? Direction is in this case, but it's not pointing here because you get negative, is pointing this way. Yeah. This is the trick. You see the value here is positive, right? Positive because of what? Direction is pointing the correct direction here. Okay. It's the same meaning. It's the same meaning. A equal to 0.791 in this direction. Equal is an equal, same diagram. If you draw something like that, if you draw direction of your acceleration towards this, but the value is negative 0.791 meter per second square. It's the same meaning. This one, your positive direction is to x direction. This one also same. Your x is positive to this direction. Only you see the a value is different. If you want to follow this one, remember what you calculate is negative. negative, it means actually the real one is flipped to another side. If you want to use the positive value, so just be careful on this one. Right. If you're confused with this one, you just follow the normal direction, follow the answer you calculate. You just draw arrow following all positive here, copy the direction, the value that you calculate in your, if you're confused lah. But try to clear this confused before you go into chapter 3, because later we don't want to have negative value in our diagram. Okay, so I hope everyone clear on how we do. Okay. Okay, the next chapter we're going to look at projectile, which is you learn in your physics. Projectile basically is an application of this Newton equation here, these three. Okay, the trick is to split these three equations into x direction, y direction, and z direction. Okay. Any question? Yeah. Okay. Okay. If no question, we end our lesson here. All right. See you on Friday. No.